Okay, so we are at day 4. So we started off with a few distributions yesterday. The first one that we studied was a uniform distribution. Okay, so why are we studying some distributions? Because the variables that we are going to see in our businesses, they also follow some kind of a distribution. So your total number of orders that you get, your profits, your revenue, your growth, okay, the number of customers you have on a daily basis, all of these might follow a certain distribution. So that is why we study a few distributions. And even a lot of machine learning algorithms are based on some distribution. A lot of algorithms, they assume that your underlying data would follow a certain distribution, and the algorithms work best when those assumptions are satisfied. So when your data follows that particular distribution, the algorithms tend to work the best. Okay, so it is important to understand at least the few basic distributions. So the first one that we saw was uniform distribution. Uniform distribution, as the name suggests, it stays uniform. It doesn't change. Okay. So if I draw the histogram of it, it would look like a straight line like this. Okay. So it won't change. So this is a uniform distribution. Now to get, we also saw in R that if you want to get random numbers from a uniform distribution, the function is runif. Okay. Runif is the function which gives you random numbers from a uniform distribution. The next one that we saw was a normal distribution. Oops. So normal distribution is the most famous distribution. Okay, it looks like a bell curve. Oops. Okay, again my diagram is not perfect. Okay, it should be symmetrical. So this is a normal distribution, also known as normal bell curve. Okay, so this distribution, any normal distribution, is always a function of the average and the standard deviation. The average lies somewhere here. Okay, and the standard deviation. So we saw yesterday that standard deviation, if you go a few standard deviations away from the mean, you capture almost all of your data if your data follows a normal distribution. So if your data follows a normal distribution, if you go a few standard deviations away from your average on both sides, you capture almost all of your data. Okay, and guys, this is true for any distribution, not only normal distribution but any distribution. So please note, when I say that, so this is very important. If you go a few standard deviations away from mean on both sides, you get almost all of your data. Okay, this is true for any distribution, not only in normal distribution. In normal distribution, if you go 3 standard deviation away, you get almost all of the data. For other distributions, it might not be 3, maybe it is 4 or 5 or 6, but if you go a few standard deviations away, you get almost all of your data. This is true for any kind of distribution. Okay, not only normal or uniform or whatever. Almost everywhere this can be true. Now in a normal distribution, if you go, we saw certain stats yesterday in a normal distribution. So if you go 1 standard deviation away, you get 68% of your data. If you go 2 standard deviation away, you get around 95% of your data. And if you go 3 standard deviation away, you get almost all of your data. Okay, if you go 3 standard deviation away, you get almost all of your data. So this is true only for normal distribution. Okay, this is not true for all distributions. This is only true for normal distribution, but this is true for all distribution. If you go a few standard deviation away, few means maybe up to 5 or 7. So beyond 7 standard deviation away, you will not find, like, very few data points is what you will find, whatever the distribution be. So even if you have a complex distribution like this, let's say this is the histogram. Okay, this is the histogram. Even in this distribution, if you go, let's say, 5 or 7 standard deviation away, you will get almost 99% of your data. So whatever be the distribution, if you go a few standard deviations away, you get almost all of your data. Okay, so this comes from a very important theorem called Chebyshev. Okay, but again, that is not required. Just that information, if you remember, is enough. Yogesh, you could not connect through laptop. Why? What's the issue? What issue did you face? Yogesh, why were you not able to? What's that? CYES. What is that? Oh yes. Yeah. Any error? Were you getting any error? Okay, guys. Sometimes what happens is you will have to delete your cookies. Okay. Okay, I think that is the problem. You will have to go to your settings and delete your cookies. So what happens is this software stores cookies, and because of that, sometimes you are not able to log in. Okay, so go to your history and delete all the cookies. So whichever browser you are using, delete all your cookies, or try some new browser that you haven't used so far. Then it should work. Okay, I forgot to tell you this. I should have told this before, because even earlier a few students had this issue. Even I have this issue sometimes. It doesn't allow me to log in. Okay, so please try that. For now, I think it should be okay. Okay, maybe during the break you can try. Okay, so this is what we saw in normal distribution. Okay, that if you go these standard deviations away, you get this much percentage of the data. Now, why is this useful to us? This is useful to us because we can study our variable in details if we know these stats. The only information we would need is if your variable follows a normal distribution or not. Okay, later we will see a test. We will see something called chi-square test, which will help us identify whether a variable follows a normal distribution or not. For now, you can just draw the histogram, and if the histogram looks something around a bell curve, you can safely assume that it follows normal distribution. Okay, so the way to identify if a variable follows a normal distribution is by drawing a histogram as of now, but later we will see a statistical test which can basically tell us whether it is or not. Okay, so we did some examples on this, and we will be doing a lot during the homework assignment. So the examples were, so the area under this curve is always 1. Okay, the proportion of data is 100%, right? So the area is 100% here. We did a few questions where we were asked to find a particular area. So it can be this shaded portion, or it can be this shaded portion. Okay, so we learned how to do this. So first what you will do is you will identify the point. Let's say xi. You will identify the point, and then if the point is 1, 2, or 3 standard deviations away, then you can use these stats. If xi is 1, 2, or 3 standard deviations away, then you already know these stats. You can directly use these stats to find out the answer. But if the point is, let's say, 1.5 standard deviation away, or any other number apart from these three, if it is any other number, then it cannot be done by hand, because this graph is not linear, right? It is a curve. So then it is not possible by hand. In that case, we use the software. Okay. So the way to do this in software is we use the p-norm function. P stands for probability, norm for normal distribution. And the syntax is like this. We write the value of xi first, then we write x bar, then we give the standard deviation, and then we give true or false. So true. So this basically stands for lower dot tail is equal to true or false. So if you want the area on the left hand side, you give true. If you want the area on the right hand side, you give false. Okay. So depending upon the question, you will decide what is the question asking you. Is it asking you the number of data points greater than some number, or is it asking you the number of data points less than some number? Accordingly, you will give true or false to your lower dot tail. Okay. So that way you can figure out the answer to any questions on normal distribution. Okay. Now, what else did we cover yesterday? Okay. Then we saw a few. So this is the stats part that we saw yesterday. Then we moved on to your R portion. So we read a CSV file in R. Okay. So we use the read.csv function for that. So read.csv and the file name. Okay. But we should make sure that this file is in your working directory. Else you can give the entire location and then read the file. So we read a CSV file, then we saw a few basic functions like str. Str function will give you the data type of each column. Okay, and a few examples it will give you. Then we saw summary function. Summary function gives you a descriptive statistics. Okay, it will give you the minimum, maximum, the first quantile, median, third quantile. So a descriptive statistics of each column, and it will additionally also give you the any values, how many missing values are present in each column. Then we saw the dimension function. Dimension of data frame will give us the number of rows and number of columns. You can alternatively get that using n row and n col also. Okay. Then we saw table function. Table function is used for a character vector. Okay. Table function is usually used for a character vector. It will tell you the number of unique characters. Okay. The number of unique characters. So for example, if a data frame has gender column, then you write something like this: data frame $gender table. This will give you how many males you have and how many female you have. It will give you directly. Okay. So that's for the table function. What else? Okay. Then we saw the write function. Okay. We saw how do we write a data frame into a CSV file. So for that we use write.csv. First we give the name of the data frame that we want to write. Then we give the name of the file. You want to write it at what name do you want to give to the CSV file? You give that. And then there is an optional argument, row names is equal to true or false. False means you will not get the serial numbers. Otherwise you will get serial numbers in your rows. So if you want to avoid that, give false. Okay. Then we saw some loops. We saw loops in R. So this is similar to other languages. We have your you have your for loop. So for I in a vector, let's say x. So x is any vector here, and then you write whatever you want to do basically. Okay, inside curly braces you can write whatever operation you want to do. Similarly, you have while loop. So while you give some condition here, so x is less than, let's say, 5. Then again similar format, curly braces, you do whatever you want to do inside this loop, and you must have a increment operator or decrement operator here. So something which changes the value of x so that the condition is violated and it comes out of the loop. Otherwise it will become an infinite loop. Okay. So that's the for loop, while loop. Then we also saw the if condition, if else condition. So the syntax for that is like this. You give if condition 1, okay, then you write else if you have multiple conditions to be tested, you write it this way, okay. Then you have, similarly you can have multiple conditions, as many conditions as you want you can have. And finally, when, what do you want to do if none of the conditions are satisfied, you write it with a else condition, okay. You write it with a else. So this is on the loops part. And then finally we saw one last thing, which is subset function. We saw how do we deal with missing values in R, okay. So the way to identify missing values is dot na, okay. Is dot na is used. We never use double equal to na, okay. Double equal to na will not work because this is something which is missing, so you cannot use equal to sign with that. Equal to sign is used for specific numbers or characters, not for something which is unknown. So is dot na is used for that. So this is how you identify missing values. So if you give is dot na and any vector here, you will get a boolean vector out. True false vector out you will get. True means it is missing, false means it is not missing, okay. Now we also learned how to create a new data frame from an existing data frame depending upon some condition. So for that there are two ways. One is indexing. You can use a normal indexing which we have seen earlier in the last week, and the other is, which we saw yesterday, was the subset function, okay. So indexing, for example, let's say you have a data frame which has a male and female, and you want to create separate data frames for male and separate for female. So you can use the indexing. So let's say df is the original data frame. You can write df dollar gender is double equal to male, let's say, okay. What does this mean? So this is data frame underscore male. This means you are taking all the male out from this column, okay, and I have given a blank here. That means all the columns will be taken and kept inside this new data frame, okay. The rows will be filtered based on this condition. I have given the condition in the rows. That means this condition will be filtered on the rows, and depending upon which rows are true for this condition, only those rows will be taken and a new data frame created, and all the columns will be coming because I have not given anything here, okay. So this is one way of doing it. Now the disadvantage here is, let's say I have gender na at some place in some rows. Let's say I have gender as na. Now those will also get inside this data frame. Even if it is na, it will get inside. That is the disadvantage of this. So some nas will get inside male as well as in female, which is what happened yesterday, okay. Now the way to remove this issue is to use the subset function. So instead of using this, we will use subset function. So the syntax of subset is, first you write the original data frame and then you write the condition. So data frame dollar gender is equal to male. So you will write this condition. This will take care of the missing value. So if a row has missing value, that will not go in either male or female. That will just be ignored, okay. So that's a advantage of using the subset function over the normal index operation. So I think this is all that we covered yesterday, right guys? So now I think we can go ahead with today's class, okay. Any doubts so far, guys? Amit, dim is a function which gives you the dimension. Dim is a function to check the dimensions of a data frame or a matrix, the number of rows, number of columns. Okay, so let's move ahead, guys. Let's see the variable types in machine learning. So we'll talk about the variable types. So this is not for any software language. Okay, this is not with respect to R, Python, SAS, or whatever. Okay, this is with respect to machine learning. This will remain common throughout. Okay, so there are two types of, and this is very important. Why this is important is because later we will decide our machine learning algorithm depending upon the variable type. Okay, depending upon the variable types, we decide our machine learning algorithms, which algorithm to use for which kind of a problem. We decide based on the variable type. Okay, so there are two things to be discussed here. Let's discuss the first one. It is dependent variable and independent variables. Okay, dependent and independent variables. Now what is that? Now let's say you have a data. Okay, let's take income for example. So we have income, we have age, we have education. So we are trying to study the income of all individuals, let's say. Okay, we are trying to study the income of all individuals in a particular location or in a city. So we have collected these variables. Okay, we have collected these variables, and let's say gender also. And we the goal of our study is to see whether income is influenced by education, gender, and age. That is the goal of our study. So whenever we start with this, what do we assume? This we assume that this is our dependent variable. Not only do we assume, but this is what basically is the goal of the study also, right? We assume that this is our dependent variable, and these variables are independent. These variables are independent. Okay, so this is our dependent variable. We assume that the income depends on age, education, and gender. And age, of course, is independent. We do not have any influence on age, or none of these other parameters influence the age. Education also is independent. The education that a individual takes is independent of at least these factors. Gender also is independent. So what we are doing is these three are our independent variables, and this is our dependent variable. Okay, and what are we trying to study here? So we are trying to study a function f. Okay, we are trying to study a function f, which basically gives us a relation between the dependent variable and the independent variable. Okay, so this is our goal of study. We are trying to find the function f which maps our income with age, education, and gender. So this is the goal of machine learning. Not only like this is just one example, but usually the goal of any machine learning problem is this. We have a few independent variables, we have a dependent variable, and our goal is to find a function f which relates the two. Okay, which relates the two. So once we have this function f, if we are given new data points for which we just know the independent variables, we can always find out what is the dependent variable. So let's say I come with an equation. So income is equal to, let's say, 5 into age plus 2 into education plus 1 into gender. So if we can find out such a equation for new values of age, education, and gender, we can compute the income for new values. Okay, but that is something we'll go later into details. So right now I just wanted to tell you what is the concept of dependent variable and independent variables. Okay, so the variable that you are trying to study, the variable that is your outcome, is your dependent variable, and all other variables are your independent variables. Okay, is this clear, guys? So your dependent variable can be sales of your products, the number of customers that are coming. So these all, your variable of interest can be your dependent variable. Okay, now that this is one kind of this is one kind of classification of variables. Okay, now let's move to the other type. Now all variables are broadly divided into two types. Okay, one is your numerical variables, variables which are numbers. Okay, the other is categorical variables. Okay, the variables which are character basically. So for example, gender, color, Okay, these are all categorical variables, and one is numerical variable. Now within numerical variable we have two divisions. One is continuous variable, the other is discrete variable. So what is continuous variable? Continuous variables are those which can take any decimal places also. Okay, so for example, your weight, your height, these are continuous variables. They can take any decimal place. So the way to identify a continuous variable is between any two values there are infinite number of other values. So for example, somebody's height can be, let's say, 172 centimeters. Somebody else's height can be 173 centimeters. Now in between these two numbers I can have infinite other numbers. I can have zero point 0.01, I can have 0.001. So there can be infinite numbers between these two numbers. So this makes this variable continuous variable. So continuous variables are those which can take any decimal form, and there can be infinite numbers between any two other numbers basically. So those variables are continuous. So your height, your weight, these are all continuous variables. Okay. Now what is discrete variable? Discrete variables are those which take whole numbers. So 1, 2, 3 and so on. They cannot take decimal places. Okay. So for example, number of children an individual have, it cannot be in decimals. So this is a discrete variable. Okay. Or in some places, in some apps, you will see the ratings that you give. The ratings that you give for certain apps. So certain apps will not allow you to give 4.5 rating or 3.5 rating. You either give 1 rating, 2, 3, 4 or 5. You cannot give 2.5 rating. So this also makes ratings a discrete variable. Okay. So this is the broad classification within numerical variables. One is continuous variable, one is discrete variable. Guys, are you following? Okay. Now let's come to the other side, which is categorical variables. Now in categorical variables, you have again two types of variables. One is called nominal, the other is ordinal. Okay. So what are nominal? So categorical variables are all categories. Okay. So for example, male, female, so all characters basically. These are all numbers, these are all characters. So nominal variables means, so these are variables where you do not have any order. Okay. So when I say do not have any order, I mean, so for example, gender. So male and female. So there is no particular order here that okay, male should come first or female should come first. There is no particular order. So this is a nominal variable. For example, color. So red, blue, green. There is no particular order. Anyone, like all are equally alike. So there is no particular order within the categories here. So these are all nominal variables. Okay, because there is no order involved. Okay. Now contrary to this, we have the ordinal variables where there is an intrinsic order in the variable. So for example, you can say that today's temperature is low, medium, high. Okay, low, medium, high. So that means there is some order involved here. So low, then medium, and then high. So there is some order involved. We know that low is the bottommost, and then medium, and then high. So this order is involved there. That is why it is called ordinal variable. So ordinal word comes from order. So ordinal. Okay, Pankaj is asking, can we consider a series like 0, 0.5, 1 as a discrete series and consider variable as discrete? Pankaj, no. In direct cases, I think no. You can actually, it depends on the problem. Sometimes that is done. So once we go to machine learning, you will see that a lot of forceful changes are done to simplify the problem. But in its original form, I would say no. But since the numbers are only 0, 0.5, 1, 1.5, and not something between them, maybe yes. But in its direct form, no. Okay. Then I think yes. Since there is nothing in between, I think yes. So let's say if you're talking about rating to an app, and the app allows you to give zero point 0.5 rating. So either you give 1 rating, 1.5, 2, 2.5, then you can consider it to be discrete. Okay. But again, right now let us not discuss that because this might confuse people. Okay. That is a little those are special cases. Okay, where you do that to simplify your machine learning problem, not otherwise. Okay. So this is the broad classification of all machine learning variables. Why are we studying this? So this is different. Okay, dependent and independent variable is with respect to your business, and this is basically in your data. This other classification is in your data. Why is this so important? Because the data type of your dependent variable decides which algorithm you will be choosing in machine learning. So I'm repeating, the data type, which type is your data? Is it numerical or is it categorical? This will decide which machine learning algorithm you will be using. Okay. And what you need to know is only if it is numerical or if it is categorical. Even if you are not sure if it is continuous or discrete, or you are not sure if it is nominal or ordinal, that is okay. What you just need to know is whether it is numerical or whether it is categorical. Okay. For example, let's say price of house, or let's say gender, for example. So gender, male and female. What is the data type? What is the variable type of this from above? Yeah, and within categorical, which one? It is nominal, right? Okay, great. Now let me change. Let me represent male by 1 and female by 0. Okay, I'm changing it now. I'm representing male by 1 and female by 0. Now what is the data type of gender? Okay, the answer is it's same as before. Okay, it is still nominal. Just because I have represented it by 1 and 0 doesn't mean that the data type will change. Okay, it is still nominal. Okay, so always remember this, guys. Even though we are representing it with numbers, that doesn't mean that the variable type changes. It would still remain the same. It will not change. Okay, it is still nominal. No, Hers. This is just a representation. This is just a representation. So if I had represented them with 1.0 and 0.0, would you tell that this is continuous? No, right? This is just a representation I have given. The variable in its original form is still male and female, and there is no order involved. Even if I am giving 1 and 0, in the original variable there is no order involved. You can never say that, let's say male is 1 and female is 0. You can never say male is greater than female. This is not possible. You have to look the original underlining variable, not the numbers that I am giving. Anand, the difference between discrete and nominal is that discrete are numbers. They are original numbers, okay? But nominals are not numbers, they are categories. Nominals are categories, color, red, blue, green. Okay, even though I might represent red by, let's say I represent red by 1, blue by 2, green by 3, but still the variable will be nominal. It will not become discrete if I represent it by 1 and 2 and 3. Okay, so always remember, we have to decide the variable by its original form, not by the numbers that we are giving. Yes, discrete can increase to any number. Need not be just 1, 2, and 3. It can be any number. It can be 1 to 100. Natural numbers are also discrete. So all natural numbers are also discrete because they cannot take decimal forms. Okay. Yes. Categorical variables generally will have few values. Yeah. So guys, this is a very uh, a difficult and confusing topic, which variable is under which class. A lot of statisticians also argue over this. You can see over the internet there are many articles where people are confused, and there is a lot of discussion going on as to what variable this should be. Okay. So but for our case, for machine learning, I think it is pretty easy. Your business problem will define which data type will it fall into. Okay. So whatever I have covered, I think that should be enough for you to be good. Okay. You don't have to go into the details of it. We will see. So we will see this again and again in the class, because before we apply any machine learning algorithm, we will be discussing this. Okay. So let's move ahead. I'll be sharing one Word document with you. So I have just copied something from the internet, so that will help you understand better. Okay. So this I have copied from somewhere in the internet, and I'll paste that link also from where I have gotten this, so you can read that. Okay. Which will help you understand better what are the different classes of variables. Okay. So let's move ahead. Okay, so let's come to the concept of PDF. Again, this is something very simple. PDF is probability density function. Okay. Probability density function. What is probability density function? It is nothing but a histogram. Okay. The moment you draw a histogram, let's say it looks like this. Okay. In a histogram, what do you have in a histogram? These are frequencies, right? These are frequency or count, right guys? And this is the variable that we are studying, and this is the frequency or the count. Now when you replace this frequency in, this is a histogram. Okay. This is a histogram. Now when you replace the frequency with probability, when you replace the frequency with probability, what you get is a, this is known as a PDF, probability density function. So the image, the graph will look exactly the same. Okay, it will look exactly the same. Only thing is, instead of frequency you will have probability here. So these numbers will be below 1. Okay. And then the area will become 1. The area of this entire curve will become 1. Are you following guys? Here it will be greater than 1 depending upon the count. Okay. But here it will be less than 1 because it is probability. So let me show you in R, then I think you will be understanding better. So let me just show it in R. So let me take a normal vector, a temp vector which has, let's say, 1 to 10. Okay. It has numbers from 1 to 10. I will draw a histogram of temp now, and it looks like this. Okay. Guys, are you following? So this is a histogram which has a height 2. So you see the height is 2. It goes till 2. This is a histogram, okay? And the bins are 0 to 2, 2 to 4. So the width of the bin, each of the bin is 2. The width of each of the bin is 2. Okay? And of course there are two numbers between 0 to 2, right? One number is 1 and the other number is 2. That is why the height is 2. Similarly, there are two numbers between 2 and 4. One is 2 and one is 3. Again, between 4 and 6, one is 4, one is 5. Between 6 and 8, one is 6, one is 7, and so on. So the height is 2. Now I will convert this to a PDF. It's very easy. I'll just change this to PDF. So to change it to PDF, I'll just write probability is equal to true. That's it. The same function, I will just change probability by default is false. I'll change it to true. Now you see, I get the same histogram, but you see the y-axis has changed now. Now I have 0.1. The bins are the same as before, but instead of having 2 here earlier, I had 2 here. Now it has changed to 0.1. Okay, because this is representing the density now. It is representing the probability. Okay, it is more commonly known as PDF, probability density function. And if you see the area of this curve, what is the area? 10 into, so width into height, 10 into 0.1, which is nothing but 1. So the area of any PDF is always 1. It is the total area, basically 100%. So area is 1 here. Okay. Is this clear, guys? So let me show you another example on this. So let's say I create another vector, and this time I take random numbers from a normal distribution. Okay, let me take 1000 random numbers from a normal distribution. Our norm will give me random numbers from a normal distribution which has its mean at 0 and standard deviation is 1. So this is my temp. Now let me draw a histogram of temp. Okay, I'll draw a histogram of temp and see, it looks like this. See, this is looking like a normal distribution, right? Because I have taken the numbers from a normal distribution. So obviously it will look like a normal distribution. Okay. Now the same, let me draw it side by side. Okay. Let me draw both the images side by side. So for this, I will use a function. I will use this function. Okay. So this function, what it does is it creates a partition in your window. So PAR stands for partition. And then I am giving 1 comma 2. That means that window, it will divide into 1 row and 2 columns. I want 2 images to be side by side, so I am doing this. So now when I draw this histogram of temp, and then I will draw histogram of temp with probability is equal to true. Okay, so right now I have one image. When I run this next command, I will have the second image. Okay, so guys, you see this, the first one is the histogram, the second one is a PDF. Okay, the second one is nothing but a PDF. You see, both are exactly same. The only difference is this has the count, this has the probability. And of course, probability cannot go above 1, so it should be below 1. So total area here is 1. Okay. So this is a normal histogram, this is a PDF. Okay. Is this clear now? So both are exactly same. There is no difference. So you have learned this function also, the partition function. So I divided my window into one row and two columns. So this first line will go as the first column, the second image will go as the second column. Hers, that is by default. That is by default. So if you go to this function r norm, okay, if you go to the help page of that function, it will show you. See, this is your r norm, right? N is the number of observations that you want. This is your n, and mean is 0, SD is 1. This is by default. You can change it if you want. You can give any other number, but by default it is 0 and 1. So that is where I got that. Okay. Significance of this PDF, Saraswati, the significance is the same as the histogram. It shows you the distribution, but only difference is it shows you the distribution in terms of probability and not in terms of count. So it has the same purpose as a histogram. In fact, many people call it a histogram also. So many people, even here you are getting the same label, right? So many people call PDF also as a histogram. So it has exactly same significance as a histogram. No difference at all. Okay, I just wanted you to know, because you should not get confused that what am I getting. I'm not getting the count. Okay, because it is the same thing. Instead of the count, it is giving you the probability. Okay, Neha is asking how did it come up with the numbers. So how did it come up with the probability? Neha, it is simple. What you do is, so let me tell you how it came with those numbers, though it is not required for you because you automatically get it. So how it is done is, let's say this count in this box we are talking about, let's say this is 3 and this is 4. Okay, let's say the height here is, let's say 5. Okay, the height is 5. We have to convert it to a probability. So what we do is, we take this 5, we divide it by the total number of samples. Okay, the total count. So let's say this is 5, this is 4, and let's say there are 50 data points here. So we divide 5 by 50. Okay, and then we also divide it by this width. So the width is 1 here, so it will be 0.1. So this is how now this height will be 0.1. So it will be 0.1 and not 5. Okay, so this is how you get it. So 5, the height of the height, okay, divided by total number of sample into the width. This is how you get the probabilities. Okay, using this formula. But you really don't have to know this. Okay, now let's move ahead. After this, let us move ahead. Okay, now let's talk about joins in R. Okay, so people who know SQL would already know this. We'll talk about joins. Okay, so all of you would have read joins in your college, or somewhere at least you would have heard of joins. Okay, joins is when you merge two tables or two data frames based on a common key. Okay, so let's say you have key in one table and another, the same variable key in another table, and you have some different columns here. You want to merge them and bring all the information into one data frame or one table. So for that we use joins. Okay, so we will talk about right join, left join, inner join, and outer join. Okay, so let me start with an example. This can be best understood using an example, but most of you would probably know this. So let's start directly in R. Okay, so let me create some dummy data frames to do that. Okay, So I'm creating some dummy data frames using the data.frame function. Okay. So my data frame will have two columns. The first column is customer ID, which is just numbers from 1 to 6, serial numbers. Then I have product. Okay. I have the second column as product. And what does it have? So if you see, this is also a vector. Okay. So what am I doing here? REP function is stands for repeat. Okay. So REP function takes two inputs. One is what do you want to repeat, and second is how many times do you want to repeat. So for example, if I write REP, let's say 1 10, so what will happen is 1 will be repeated 10 times. Okay. So REP function takes two inputs. One is what do you want to repeat, second is how many times do you want to repeat. So here I want to repeat toaster 3 times. Okay. So if I run only this, I will get toaster. Okay, I forgot to give the bracket. I'll get toaster 3 times because I have written repeat toaster 3. Similarly, if I run this, I'll get radio 3 times. Oh, I gave an additional bracket here. Okay, I'll get radio 3 times. So my first data frame, if I run this and if I show you my first data frame, it looks like this. I have customer ID numbers from 1 to 6 as I have given here, and then I have product. First 3 are toasters, second 3 are radio. Okay. One sec, please hold. Okay. Okay guys, sorry about that. Okay, so I have created my first data frame, which is this, and similarly I'll create another data frame. Okay, so here I have some customer IDs. Okay, and I have some state. So these are some states in the US. So I have some states here. So the second data frame, if I run it, it looks like this. It has only 3 rows. So these are the two data frames that I have. Okay, now if you see, they have a common column, which is customer ID. Okay, they have a common column called customer ID. Now I will try to merge the two. So I want one table which has customer ID, which has product information, and which has the state information of the customer. Okay, so let's see in what different ways can we do this. Okay, so the first one, let's go by this. The first one that I have here is outer join. Okay, so outer join. So let's say we have customer ID, we have product. This is 1 2 3, let's say A B C, and I have another table which is again customer ID and state. Okay, let's say 2 and 4, let's say X and Y. Okay, so first we will be doing a outer join here. So between these two tables, and guys, one thing to note here is that this is totally different than R bind and C bind. Okay, R bind and C bind is used when your data is intrinsically the same. So in R bind, your column names should be exactly same, the number of columns should be exactly same. So those are two same data frames basically. They cannot be different data frames. Similarly, C bind is used for two data frames which has the same number of rows. Okay, but joins can be done in any type of data frame. So you can have one data frame which has 100 rows and some 50 columns. You can have another data frame which has 10 rows and 10 columns. It can be done between any data frames together. Okay, so this is table number 1. Let's say this is data frame 1, this is data frame 2. Now first is we will do a outer join. So first let's understand the concept and then we will see how to code it. So what is outer join? if you know outer join, you do a outer join when you don't want to lose any information. Okay, so the points to note here is no information loss. Okay, you will not lose any information if you do a outer join. No information loss, but the flip side is you will get NA values. Okay, you will get NA values, but you will not lose any information. So for example, if I do a outer join here, what will I get? So I will get customer ID, I will get product information, and I will get state. So let's start. I'll have 1 2 3 here. I'll have A B C here. Now what is the state corresponding to 1? I don't have it, so I will get a NA here. Okay, what is the state corresponding to 2? It is X, so I will get X here. Corresponding to 3 I do not have, so I will get a NA. And 4 state is Y. Do I have the product for customer ID 4? No, I do not have the product for customer ID 4, so this will be a NA. So this is the final output you will get if you do a outer join on these two tables, on these two data frames. Now you see, have you lost any information here? Have you lost any information in this table? No, right? You have all the information. You haven't lost any information, but the flip side is you have some NA values. You have these missing values, which is unavoidable. If you remove this, you will have to remove this entire row. You cannot just remove this, right? So this has no information loss, but this has missing values. So this is outer join. Okay, this is outer join. Now similar to this, or rather opposite to this, is inner join. So in inner join, what happens? You no missing values. You will not have any NA values. Okay, but the flip side is you lose information. You will lose information. So let's do a inner join on this table. So customer ID, product, state. So customer ID is so in inner join you will get only those rows which are common to both. Okay, so 1, if I cannot add 1, right, because 1 doesn't have the state number, so it will give us missing values for state, so I will not have 1 here. 2 is present in both, so I will have 2. So 2 B and X. Again 4 has missing value for product, so I cannot have 4 here also, so this will be my answer. This is your inner join. So you see the difference now, right? This doesn't have any missing value, but you have lost some information. Now you don't know what is the product customer number 1 bought, or what is the product customer number 3 bought, or you don't know what is the state of customer ID 4. So you have lost that information, but you don't have any missing value. This is inner join. Is it clear, guys? What is inner join? What is outer join? Okay, so Mohit is asking, what if you had a customer ID 3 with a NA already? Then it would come, Mohit. Then it would come. So let's say you have a customer ID 3 with a NA here. Then it will come here, because that is intrinsic to the value. Okay, that is present already in the value, then it would come. But I am saying these NAs, I mean the NAs which come while merging. Now you can treat this NA as a value. Okay, you can treat this NA as a value itself, then it will certainly come. So let's say I have NA here. Okay, then, or let's say in place of, let me take 4 here, and I have a NA here, then it would certainly come. So I'll have 4, I'll have state is Y, and I will have a NA here. That is because, so you'll have to look at customer ID column only. Look at customer ID column, don't look at these, because you are merging based on customer ID. So only things which are common to customer ID in both will appear. Since I have 2 here, I have 4 here, it will come. I have 2 here, I have 4 here, so it will come here. Okay, we don't have to look at these. Okay, yeah, now let's look at left join and right join also. Right join is not popularly used. We usually use left join mostly. So what is left join now? Left join, when you say left join or when you say right join, then the ordering becomes important. The ordering of the table becomes important. What do I mean by ordering? By ordering, I mean which table are you considering as your base. So whenever you do a left join, you consider some table as your base and you try to stick the other table along with it. Okay. So let's say I'm considering my data frame 1 as base. When I do a left join, so left join and right join, they are in between these two. They are neither outer join, they are nor inner join. They are somewhere in between. Okay. So what do you do in left join? Let's say if you consider data frame 1 as your left table, this is your base table, or the left table, you can say this is your base. So whenever you consider data frame 1 as your base, you will not lose any information from data frame 1. So your data frame 1 will come as it is. So what is the data frame 1? Let me write it down. So 1 2 3 4. Okay. So A, B, and two NAs I have. So A, B, NA, NA. So this is my data frame 1. Yes, exactly, Neha. That is correct. Okay. So since I have given data frame 1 as my base, I will get all details from my data frame 1. I will not lose any information from data frame 1. So what is my data frame 1? This one. So I have written everything that I have from data frame 1 here. Now I will bring only those columns, only those values which are common to data frame 2 here. So I have data frame 2 and I have customer ID 2 and customer ID 4. So customer ID 2, it is X, customer ID 4, it is Y, and of course this will become NA. So these becomes NA. So this is what you will get if you do a left join with data frame 1 as your left side data frame or as your left side table. Okay. Similarly, if I do a right join in this order, okay, I will get my right side data frame first. So df2 will come as it is. So my df2 is 24xy. Okay. And now it will start looking in df1. Is customer ID 2 present in df1? Yes. So it will bring the product here. Is customer ID 4 present in df1? Yes. And the product ID is NA. So it will bring NA here. And this is what you will get, your final table. Okay. So the point is, when you do a left join or a right join, your left side table comes as it is. Your left side table comes as it is, and then all details from the right hand side table which have a match in your left hand side table will start coming in. Okay. Similarly, when you do a right join, your right side table comes as it is, and then you start bringing in things which match from the left side table. Okay. Clear, guys? Are these two things clear? Okay. So let's see how do we do them in R. It's very simple. The same function is used with slight changes. Okay. So remember these two tables that we created here. Now we will try to do all these 4 joins in them. So let's do a outer join first. So to do outer join, so merge function is used for that. Okay. Merge function does that. So you write merge and then you write your first data frame. So I have written X is equal to df1. So this is my first data frame that I want to merge. Y is equal to df2. So this is the second data frame that I want to merge. Now I write by is equal to customer ID. So based on which column do you want to merge? That you have to provide, right? So I want to merge based on customer ID. So I have given customer ID here. And when I write all is equal to true, this is nothing but outer join. You understood, right, what outer join does? Outer join, basically you will not lose any information. You will have missing values, but you will not lose any information. So all is equal to true. That means I don't want to lose any information. So when you run this, see, you will get NA values, but you will not lose any information. And this is what you are getting. You are not losing any information from the two tables. So this is your data frame 1, this is your data frame 2. when you do a outer join, this is what you get. So all information is retained. We don't lose any information here. We have some missing values though. Okay. Next, let's do a left join now. Let's do a inner join first. So when you do a inner join, you just remove this all is equal to true. Okay. You don't give this. So when the moment you don't give this, by default it does a inner join. So this is what is for inner join. You just run this and you see I'm getting only customers which are common. So this is the outer join and this one is the inner join. You see these rows were removed. The rows which had NAs were removed basically. So you have only 3 rows now, 2, 4 and 6, which are common to both the tables. Okay. Similarly, you have left join. So in the left join, what you will do, you will write all dot x is equal to true. That means x is nothing but your left hand side table. Okay. So you want everything from your left hand side table. That is what you are writing here. So this is nothing but left join. So if I run this, I will get all details from my left side table, which is data frame 1. Okay. Right hand side table, I will get only the matches. Similarly, a right join, I will write all dot y is equal to true. So very intuitive. The codes are very intuitive. Same code, slight changes in parameters, and you can do whatever join you want to do. Left join, right join, inner join, outer join. Okay. Did you follow, guys? I'm sure you will understand this. Just do a few examples, and this is a very easy thing. This is not something difficult. Okay, just merging two tables together based on a common key. Very intuitive. Okay, now a question to be asked here is, what if my column names were different? What if my column was called customer ID in the first data frame? So right now both table has customer ID, right? What if my column name was different? What if it was called only ID in the second data frame? So in that case, one way to do it is change the column name in the other, and then merge. The other way is you can use the, so instead of writing by, you can write by dot x also. So the moment you write by dot x, you can give the name of the column in the first data frame, and you can give the name of the column in the second data frame. So in that case, even if the column names are different, it will still go ahead and merge. So let me show you. Let me change the column name to just ID in the first data frame. Okay, I'll change the column name to only ID in the first data frame. So now my first data frame has only ID and my second data frame has customer ID, and then I will try to do a, let's say, inner join. Okay, so of course when I do this it will throw an error because I have customer ID only in the second data frame. In the first data frame it is ID, so it is throwing an error. Okay, that by must specify a uniquely valid column, so it should be in both the data frames is what it is telling you. So what I will do to avoid that, I will write by dot x is equal to ID. Okay, because my column name is in the x table, x is nothing but df1, so my column name is ID in my first table and my column name is customer ID in my second table. So I will use this to merge, and see it is merging now. Okay, so you can even change your column names, or you can, even if you have different names, you can still merge. You don't have to basically change the column names. Okay, was this clear, guys? How to merge if the column names are different? Okay, and now if somebody asks me how do we change the column name, Pankaj, similarly you can give two columns also. You will have to pass the columns as a vector. In that case you can merge based on two columns also. You will have to pass as a vector. So by dot x, what you will write is, let's say by is equal to, as a vector you will pass the two columns. Okay, let's say column number A, column number B. This way you will work. Okay, This way you can do using 2 columns also. Okay, so if you ask me how do we change column names, so column names data frame, this is a function which is used to get all the column names in a data frame. Okay, so the moment you write call names and data frame, you get all the columns in that data frame. So this is nothing but a vector. So if you want to change any one of them, let's say I want to change the second one, so I will access the second one using the index 2, and then I can give whatever name I want to give. Let's say I gave P. So next again when I look at df1, I will have P instead of product because I just changed it here. Okay, so this way you can change your column names if you want. So let me just undo the changes that I made. This should be just let me make this notes, otherwise I'll forget to save it. Okay, yeah, I'm done here. Okay, so that's all about merging two data frames together, okay, using a common key. So it has the same concept as any in any language. So in Python also you do the same thing, in SQL you do the same thing. The code is a little different. The code here actually is very similar to what you have in Python. In Python also, if anybody here who knows a little bit of Python, in Python also we use the same function. There also you have the merge function. Okay, in SQL I'm not very sure, I did it long time ago. I think it should be merged there also. Okay, so let's go to the next topic. Let's take a small topic and then we will take a break. Okay, okay, let's see how do we draw a scatter plot. So guys, if you remember, what kind of plots have we seen so far? We have seen histograms and we have seen box plots, right? We have seen histogram and we have seen box plot so far. Okay, now all of this comes under univariate analysis, right guys? Univariate because in histogram you draw the histogram of only one variable, and box plot also you draw for one variable. You never draw a box plot for two variables simultaneously, or a histogram for two variables simultaneously. You do it one variable at a time. So this comes under univariate analysis. Now similarly we can also do bivariate analysis. Okay, bivariate analysis means we'll be analyzing two variables simultaneously. So one way to do that is we draw a scatter plot. So scatter plot is what you would have seen probably in your school or wherever. Okay, scatter plot is where you have a x-axis and you have a y-axis, and the points are represented like this along with their coordinates. So based on their coordinates they are plotted. Obviously there are two variables involved, so let's say you might have age and you might have income here. Okay, so this is a scatter plot. Okay, so let's see how do we draw this in R. So it's very simple. We use the plot function for this. Okay, we use the plot function for it. So plot function, if you go to the, so let me first draw scatter plot. So first let us create some variables. Let me create age. Okay, so I will create a vector called age, And sample function, what it does is it picks a random sample from a given a given population. So let's say my population is 45. I'm just punching some random numbers. Okay, so this is my population and I want, let's say, 5 numbers from here. Okay, so basically this is intentionally I'm trying to do it in a difficult way because I want you to know what is the sample function. Sample function, what it does is you give it a vector. From that vector it selects randomly some values as the input that you give. So what it will do here is it will select 5 numbers randomly from these list of numbers that I have given. So now if I show you what is age, you see it is giving me these numbers. So 45 is already present here, 23 is again present here, 12 is again present here. So it is giving me 5 numbers from here, and these numbers are picked randomly with replacement. Okay, you see 23 two times, 3 times in fact. So the numbers are picked with replacement. Let me make it 33. And again, these are random numbers. Oops. Okay, so now if I run it again, it will be different. Okay, so these are the numbers I'm getting. I have picked 5 random numbers from this list. So this is my age. Let's say I'll give my income now. Income, let me write down some numbers. Okay, let's say this is income. Now I want to draw a scatter plot of the two. So the function is very simple. I write plot. I write my x variable first. So I want age to be my x variable, and then I want income to be my y variable, and I run this. Okay, so when I run this, you see I'm getting this scatter plot which has age on my x-axis and income on my y-axis, and these are the coordinates of the points. So you see the first point is 4530. So 4530 is this point, 45 and 30, right? So it should be somewhere here, right? No, not 45. The first point is 43 and 33, and okay, age is 33, 33 and 30. So this point, this is your first point. Okay, and so on. So this is your scatter plot. Again, you can do some variants here. So you can give type is equal to, within quotes you can write L. So what this will do, L stands for line. It will connect the dots with a line. So it doesn't make sense here, but in some places it will. So I have just connected the dots with line. Okay, if you give P, it will draw points. So points is by default. If you give B, it will draw both points and lines. So see, you have both points and lines now. Okay, so all variants of plot you can know from the help page of plot function. So just write question mark plot and you will get to the help page, which gives you the entire functioning. So you see these are the options that you can give in type. So type P is for points, L is for lines, B is for both points and lines. Okay, and other variants also you have. Okay, and of course you can give the labels here also. So X lab you can use to give the labels, Y lab you can use, main is for the overall title of the plot, and so on. Here are some examples also. Okay, so let's see this example. So plot, they are taking random numbers from a normal distribution. So they are taking 47 random numbers. Type is equal to S. They have given S stands for stair steps. Okay, and they have a title here. So let's copy paste this and see what we get. Let's just copy paste this. So this is what it gives. See, so what have they done? Let's see the inputs. What did they do to generate this? The first input is they have given the first they have taken 47 random numbers from a normal distribution. Okay, They have taken 47 random numbers from a normal distribution and they have used the sort function. So sort function, what it does, it arranges the number in increasing order. Okay, arranges the numbers in increasing order. So all the 47 random numbers it has arranged in increasing order. Okay, type is equal to S, it stands for staircase. Okay, and this is nothing but just the title. So this is what they are getting. Okay, so this is the plot function which is used to draw a two-dimensional plot. Okay, so guys, yeah, Neha, type is equal to S we just saw, right? Type is equal to S is for that staircase. Let me show you again. Here, S is for stair steps. So it's a type of plot basically. S is for stair steps. Okay. So let me try type is equal to S here and see if it makes sense for this small simple plot. So this is what you will get. If I type stairs in my plot, but it doesn't make sense, of course. So to type a staircase, you will have to first arrange the numbers in increasing or decreasing order. Only then type S will make sense. Okay. Okay, guys. So let's take a break. Let's take a quick break. Uh, in the second example, there is only one variable. Yes, yes. In the second example, there is only one variable because they have given type is equal to S. So if you give type is equal to S, you don't need the Y variable because automatically it will take the stairs. Okay, because you are telling it to go in increments, in stairs. So you don't exactly need the Y variable. How we decrease number here using sort? You mean in descending order? Yes, Amit, that is true. So let me give. Neha, I didn't get your question. Can you repeat? Okay, descending order. So Neha, you just give. So for example, sort. Let's say I want to sort 1, 3, 5, 2, 65, 11. If I want to sort this, see, I use the sort function. So actually, sort function I was about to cover. So it is there. So next, after the break, we will see these functions where we have sort function also. But let me cover it now only since we have come to it. So sort function, if you see, it sorted the numbers in increasing order. If you want in decreasing order, what you can do, there is an optional argument. The optional argument is decreasing. You see here, this is the optional argument. Decreasing is equal to true you give. Then it will arrange in decreasing order. Okay, by default it is false, so it arranges in ascending order. Okay, you can always go to the sort function help page and see what is the syntax. So this is how we learn. Of course, it is not possible to know all the functions, but you can always refer to the help page. So see, decreasing is equal to false, it is written clearly here, so we can use that. Okay. Okay guys, let's take a quick break. So it's 9:30, let's resume at 9:40. Okay. Okay, so I'll see you again at 9:40. Okay, see you guys. Okay. uh Vikas, you have a question, you raised your hand. Okay. Okay, next we will see a few basic functions. So before we go into any smaller functions, let us see the apply group of functions. Okay, so there's a very famous, or should I say infamous, because of its trickiness. There is an entire apply family of functions in R. Okay, apply functions. Okay, so let us see what are these apply functions and why are they safe for me. There's an entire series of apply functions. Okay, there's not only one, there are around 4 or 5 apply functions. One is apply. Okay, the other is t apply, the other is l apply, then you have s apply, you have some more. I think there is one m apply also, but these 4, if you know, it is more than enough. Okay, so let's see what are these with an example. Okay, let's go to R and directly learn there. It will be easier in that way. Okay, and again, these functions are very useful. Okay, if you know these functions, you can do a lot of things in a by writing just one line of code instead of writing an entire function for it. Okay, so try to learn as much as possible. These are a little difficult, but it is very useful. Okay, and slowly with experience you will know these. Okay, so let's take a sample data set and then we will be doing something on that sample data using apply function. Okay, so I will take a data set which is called the iris data set. So the iris data set looks like this is a very famous data set which is inbuilt in R already has this data, and it looks like this. So iris is a species of flower, is the name of a flower. Okay, iris is the name of a flower, and this is how the data looks like. So it has 5 columns. 4 columns, they are a measure of the flower's features. So sepal length, if you guys know, sepal is the bottom portion of a flower. Okay, uh, below its below its petal, basically you have the sepal, and petal is nothing but the flower itself, the top portion of the flower. Okay, I don't know what to call it. Maybe you guys would have read it in biology. Okay, so you have sepal length, sepal width, petal width, and you have the species of flower. So there are 3 species of flower. One is this setosa, one is versicolor, and one is virginica. So these are 3 species of flowers, and we have these 4 details for them. Okay, so this is the sample data that we'll be using just to see this. Okay, so yesterday we saw the functions, right? Let us just do a quick recap of those functions. We saw str yesterday, so let me run this str iris. So my data frame's name is iris. So when I run str iris, see, this is what I get. So sepal length is numerical with these few values. Sepal width, petal width is also numerical. Okay, now species, do you see something called factor here? Now what is this factor? So to understand this, what you'll have to recollect what we discussed at the beginning of today's class. Categorical variables. Okay, so beginning of the class we discussed categorical variables. So all categorical variables are read as factors in R by default. Okay, so whenever you have a categorical variable, it can be anything. It can be nominal, it can be ordinal. All categorical variables are by default read as factors in R. So that is why, since species is nothing but categorical, right? You have 3 names here. So setosa, versicolor, and virginica. So these are categorical variables. So they will be read as factors in R. Okay. So they are being read as factors in R, and it is showing you the first 2, versicolor and setosa. It is showing you. Okay. And these levels are nothing but the unique values. So setosa, versicolor, 3 levels it is showing you, right? That means it is telling you that there are 3 unique values in this column. Okay, so all character variables or all categorical variables are read as factors in R. Okay guys, is this clear? So factor is just a data type in R. Okay, so str we have seen. Now let's see the summary function. Okay, summary of iris, this also we saw yesterday. So it is giving you the same thing, the descriptive statistics for sepal length. These four columns, it is giving you the descriptive statistics. Okay, but do you see something strange here? For species column, it is giving you the count. It is giving you count of each flower type, or count of each category, or count of each factor. So this is what summary function does. Because see, species is a categorical variable. The minimum, the first quantile, the median of a categorical variable wouldn't make sense. Guys, are you following? The minimum of a category will not make sense, right? What is the minimum of a species of flower? You have three species, Setosa, versicolor, virginica. The minimum of that doesn't make sense. The first quantile of that doesn't make sense. The median of that doesn't make sense because it is not a number, it is a category. So in such cases, where you have categories involved, summary function will give you the count. Okay, but if it is a numerical variable, it will give you these these quantities: minimum, first quantile, median, and so on. But if it is categorical, if it is a factor variable, it will give you the unique counts. So Setosa, there are 50 rows with Setosa, there are 50 rows with virginica, and there are 50 rows with versicolor. Guys, are you following? Okay, great. Okay, so that's the summary function. Now let's come to this function head. I think the head was not covered yesterday. So what does head function do? So head function, what does head mean? Head means the top portion of our body, right? The topmost portion of our body. So similarly, head function, what it does, by default it will give you the top 6 rows. Okay, so see, it is giving me the top 6 rows of any data frame. So any data frame, if you want to have a look at the data frame, you cannot write iris, right? If you just write iris and press enter, it will just fill your screen. You will see all the columns. Now imagine if you have 10,000 rows, all the 10,000 rows will be printed. Okay, it doesn't make sense to look everything. So sometimes what we wish is, can we have a look at just the first few rows so that we get an idea of the data? So for that we use the head function. So head function will show you the first 6 rows. By default it will show you the first 6 rows. If you want to see more than 6, you can write that number here. Let's say I want to see the first 10 rows. So I will write head, name of the data frame, comma, how many rows do you want to see? I want to see 10 rows, so I am getting 10 rows here. You can give a smaller number also. You can give 2. Then you will get only top 2 rows. Okay, if you don't give anything, the default number is 6. So I will show you the top 6 rows. Okay, and it is showing you the top 6 rows. The first 6 rows it is showing you. Okay, so this is the head function. Similar to this, we have the tail function. So you would have guessed already, tail function will give me the bottom 6 rows. Okay, you see the index here, 145 till 150. We have 150 rows in this data set. Okay, so this is giving you the bottom 6 rows now. Similarly in tail also, if you want the bottom 10, you can write comma 10 here, and so on. Okay, so guys, head and tail function, is that clear? Okay, now let us start with the apply functions. Okay, now let's start with the apply group of functions. So first we will learn to use apply on a matrix because it is easier, and then we will come to a data frame. Okay, so this is the syntax. You write apply. Okay, we'll see the syntax later. First let's do it once. So I have created a matrix. So this is the matrix that I have created. Okay, I have created a matrix here. Now let's say my task is to find the row sum. I want to find the sum of each row. So I want 6 as the answer in the first row. I want 8 as the answer in the second, 10 as the answer in the third row, and 12 as the answer in the fourth row. So how do I find the sum now? How do I find the sum of the matrix? So without apply function, you will probably have to create a loop, right guys? you'll have to create a for loop as we learned yesterday, and using the for loop you can find the sum. So apply function, it reduces the effort. You don't have to write a loop. What you can do is just write apply. Okay, write the name of the matrix, whatever object it is. In this case it is a matrix. Write the name of the matrix, and this one stands for row operation. I want to find the row sum, right? I want to find the row sum, so I have given 1 here. And then whatever you want to find, if you want to find the sum, write sum here. So if I run this now, see what I am getting. I am getting the sum of each row, 6, 8, 10 and 12. Okay, so apply function, using apply function you can avoid writing loops, and this is very efficient also. This is very fast. Okay, you can avoid writing loops and you can directly get the sum of each row. Okay, so 1 is used for row and 2 is used for column. Okay, 1 is used for rows. If you want to do a row operation, you write 1 in the middle. If you want to do a column operation, you write 2 in the middle. Okay, similarly if I want to find the column sum now, so same matrix, this is my matrix. Now I want to find the column sum. Okay, so what will I write? I will write apply. I'll write the name of the matrix, which is met. Now since I want to find the column sum, I will write 2 here. And then what do I want to find? I want to find the sum, so I will write sum here. So see, I'm getting the column sum. The sum of the first column is 10, sum of the second column is 26. Okay, you don't have to write a loop for this. You can easily use the sum function, the apply function. Now a equivalent of this is row sum. You could have also used row sums. There is already an inbuilt function in R which finds the sum of a row, of rows in a matrix. So row sums also you could have used. So row sums mat will also give me the same answer. It will give me the sum of each row in the matrix. Similarly we have call sums also, which will give me the column sum of a matrix. Okay, but apply function can be used for anything. Even if you want to find, let's say, the standard deviation of each row, so you can use apply the matrix name of each row, let's say SD. So this will give me the standard deviation of each row. So this is the standard deviation of each row. Now you do not have a row standard deviation function like you have row sums function here. You may not have a row standard deviation. You do not have basically a row standard deviation function. Only for sum you have an inbuilt function. For other operations you do not have an inbuilt function. So you will have to use the apply function. There is no other way. Okay, so just to recollect, apply function, the syntax is you write apply. Okay, then you write the object. So by object I mean what do you want to do the operation on. You want to do it on a matrix, you want to do it on a data frame, whatever. So write that object here. Then write 1 comma 2. 1 is for row, 2 is for column, and then write the operation that you want to do. So you may want to do the sum, you may want to find the maximum, you may want to find the minimum or standard deviation, or you can also write a function of your own. Okay, you can also write a function of your own if you have to. So this is the syntax of apply function. Okay, first the object, then 1 or 2, and the operation that you want to do. Okay, based on the row or the column. Clear guys? Is this clear, the apply function? Yeah, Neha, we are yet to learn that. So that will also be covered today. So you see, I have this which will tell you how to write your own functions. Okay. Okay. So this is the apply function. Now let's move to the next one, which is tapply. So the next one is tapply. So tapply, what is this used for? Let's see with an example. So again, let's go to our iris dataset. So if you remember, this is how the iris dataset looked like. Now let's say if I ask you what is the average, let's say petal size, petal width, petal length, sepal width, sepal length of each species of flower. Okay, so what I'm asking is what is the average, what is the average sepal length, what is the average sepal width, what is the average petal length and average petal width of each species of flower. Okay, of each species of flower I'm asking. So for versicolor you will have to tell me what is the average parameter. For virginica also you will have to tell me what is the average parameter. So how will you do that? So if you don't know tapply, it will become very difficult. What you will have to do is you will have to go on like this. You will write the mean. Okay, mean of date, mean of iris. Then you will write iris dollar species is equal to setosa, and then you will write C of 1:4. Right guys, this is what you will have to do. And then again you will have to repeat for versicolor and then for virginica, right? You will have to do this to find the average of all four columns. So I'm asking the average of all four columns. This is what you will have to do. Okay, so it becomes a little tedious for a small task like this. If you have to do this 3 times, it becomes a little tedious. So that is where tapply is very helpful. Okay, so let me tell you what is the syntax of tapply. So the syntax goes like this. You write tapply. Okay, now tapply takes 3 inputs. It takes 3 inputs. The first input is what do you want to find. You want to find like, okay, the third input is what do you want to find. Okay, third input is what operation do you want to do. So I want to find the mean, so I will write mean here. Okay, what operation do you want to do, that you write as the third input. Okay, then coming to the first one, on which column do you want to apply this operation, on which column do you want to apply this operation. So I want to apply this operation on, let's say, the first 4 columns. So I will write iris all the rows and I will select 1:4. So the first 4 columns. Okay, I will select the first 4 columns of iris. Now you want to apply this operation on this data set. Now the second option is based on what category do you want to apply this. So I want to apply this based on the species category. So that will be your second input. Okay, so what the tapply will do is it will divide the entire data set based on the second input. Okay, so just watch what I'm telling you, notice what I'm telling you. Tapply function will divide the data set based on the second input and then it will apply the third input on the first input. Did you follow? Tapply will divide the data set based on the second input and then apply the third input on the first input. So it will divide the data into species. We have 3 species, so it will divide the data into 3 parts and then for each part it will apply mean on the 4 columns. Okay, did you follow guys? So it will take some time for you to remember this syntax. Anand, because I want to find the average of all the 4 columns. I want to find the average of all the first 4 columns. I cannot find the average of the 5th column, right? So if I give 5th column, it will throw error because the 5th column is a categorical column. Okay, so let me do this. Let me see if I have this already done here. Okay, I have done here, but only for 1 column I have done here. So I have done here for only 1 column. So average sepal length of each species of flower. If I run this, you see I'm getting the average for all. all the three types of flower. So I have done only for sepal length here. So sepal length, the average sepal length is 5. The average sepal length for setosa flower is 5. Average sepal length for versicolor is 5.9. Average sepal length for virginica is 6.5. Okay, I could have done the same for all the 4 also. So if I have to do that, I will use iris 1:4. Oops. Arguments must have the same length. Okay, I think it cannot be done for more than one. You will have to use no, C is not mandatory. If you're using colon, C is not mandatory. Okay, so no, you can do it only one at a time, not for all the 4 together. One at a time you can do. So only one at a time you will be able to do. So let me try something else. Okay, no, you can do it only one at a time. Okay, only one column at a time you can do. So either select sepal length, sepal weight, and then you will be able to do. Okay, so that is the T apply for you. Very useful. In some cases it is very useful. For example, if you are asked to do things like this, whatever we did now, so ignore this. Okay guys, this will not work. It will only work with one column at a time. So let's say you want to find the average of petal length of all flowers, of all 3 species of flowers, then you can use this. Okay, okay, now let's come to the next one. So T apply, we are clear with T apply what it does. Okay, so let me, I've written here. Okay, so this comment will help you understand. T apply first divides the data by the categorical variable, and the second input guys will always be a categorical variable. Okay, always make sure that the second input that you give, this particular input, it is a categorical variable. You cannot divide your data based on numbers. Okay, it will be very difficult. So how will you divide based on numbers? There will be so many smaller divisions created if you do that. So always the second input is always a categorical variable. Okay, so that's what I have written here. First divides the data by the categorical variable and then applies the function on the numerical variable. Applies the function, let me write it down here. Applies the third input on the numerical variable, which is your first input. Okay, so this will make it clear to understand. Okay, now let us come to the other 2 functions which remains. So T apply is done, so apply is done, T apply is done. Now let us come to L apply. Okay, let's come to L apply. So guys, you will take some time to remember these functions, but once you practice, you'll become comfortable in it. I will send some homework which will have applications of this under different scenarios. Okay, so that will give you some practice and that will give you some idea where these functions can be used. Okay, so now let us look at S apply. So S apply, the syntax is first you write the object. Okay, object in the sense whether it is a matrix or it is a data frame, on what do you want to run that function, and then you write that function. What function do you want to run? So for example, object can be matrix, data frame, function can be anything. So for example, S apply, so let's say you want to find the average. You want to find the average of all columns on your iris dataset. So for that you can run this. See, you get the average of all columns. So you are not getting this with respect to the flowers, with respect to the species of flowers, but with overall average you can find like this. Okay, the overall average. So if you are thinking that why can't we do this, so let me try this. Iris -5. You cannot do this. See, it is returning you something. Okay, no, iris. This will not work. Okay, you will have to use the sapply function for this. You can find the average of one column. So I can write iris dollar the first one, let's say. This will give you the average. But if you have to find the average of first four column, then this doesn't work. Okay, so you will have to use the apply function. Guys, are you following why apply function is so important? Sapply function. Because if I tell you that find the average of first four columns, you will not be able to find using just the average function. It will not work. You just saw, right? This is how you would do, right? If you have to find the average of first four columns, this is how you would try to do. But this is not working. See, it is not working. So the only way is to use sapply function. So you write sapply, you give the name of all the columns that you want to find. So I have given -5. Why -5? Because I don't want to find the average of the fifth column. My fifth column is a categorical variable. It is the species of flower. So I cannot find the average of species of flowers. So I'm excluding that. Okay, I'm excluding that, and then I'm finding the average. So this is your sapply function. It gives you the average of all the four columns. Okay, now lapply is very similar to sapply. Okay, lapply, if I run this, the syntax is exactly same. The only difference is that the output of lapply is a list. That is why you have the L written at the first. Okay, the output of lapply is the same as sapply, but the output is of type list. So see, when I run this, I get the same answer, but I'm getting it as a list. So see, 5.84, 5.84, 3.05, 3.05, 3.75, and this one. So I get the same output, but it is coming as a list. Okay. So if I check the class of this entire thing, you will see it is a list. I'm getting a list here. That's the only difference between sapply and lapply. Guys, are you clear? Okay, what is the difference between apply and sapply, right? Okay, let's see. Let's try for ourselves. So I give apply, and let's say I give this input. And what do I want to do? I want to do a column operation, right? I want to find the average of all the columns. So I run this. There is no difference. It is giving me the same output. See, so sapply and apply is giving me the same output. So first one I have done apply, second one I have done sapply. So both are giving me the same output. There's no difference. sapply you can use only for columns. That is the difference. You cannot use sapply for rows, but apply you can use for rows also. So right now, since we are doing for columns, they are giving the same answer. But if you have to do something on the rows, sapply will not work. Okay, that is the difference. But we usually do operations on columns and not on rows. So that is where apply function is not very popular, because we usually try to find average or maximum or minimum or standard deviation of a column, not of a row, because a row might have different kinds of values. It might have your age, your income, your total years of experience, your education. We will never want to find one operation on all these variables, because each variable is representing different things. Okay, so that we generally do not do. So apply is not very popular. sapply is very popular, and sapply works only on columns. Okay, so is the apply function clear, guys? We have covered all the four. Okay, lapply, sapply. So the output of this is a list. Just remember this. This one and this one are same, but this one gives the output as a list. This one gives the output as a vector. Okay. tapply you already saw. It divides your data into smaller pieces based on the second input, and then runs the third input on the first input. Okay, apply function is similar to lapply, but it can be used for rows as well. There are a few more apply functions. There is one mapply, but these four, if you remember, it's more than enough. Okay. Okay. So now let us see their application. So we have seen very small examples, right? We have seen small examples where we used apply function or apply family of functions, whichever one. We used normal apply function, we used tapply, sapply, and lapply. But we really have to see one application where they are actually used in the industry. Where do we actually use the apply functions? Okay. So of course we will see this a lot later when we start with the case studies and when we start with the machine learning algorithms. But just to give you a heads up on that, where do we use, let's see a few examples. So I have included a few a little complicated examples where sapply or lapply is being used. Okay. So these are a few examples where we can use lapply, sapply. But to understand this, first we will have to understand how do we write our own functions in R. So let us go to that piece first, and then we'll come back here and then try to understand these applications. Okay, because if you remember, I mentioned, right, that with sapply you can use any function of your own as well, right? So the syntax of apply is this. Okay, so this function can be any function. So instead of, where is that? Yeah, it's here. So sapply object and function. So this function can be any function. It can be your own user defined function also. Okay, so we will see application of that. But before that, let's see how do we create user defined functions in R. Okay, again, that is very simple. Let's see a few small examples, like how do you write a function to find even numbers from given numbers and so on. We will see smaller functions. If you want more rigorous exercise on this, you can refer to this link. So I have shared the link here. At this website you will find a few examples where they have done some more complicated functions. Pankaj is asking, can you validate result of sapply? Matrix 1 to 20. Okay. Okay. You want me to validate whatever you have pasted right now, Pankaj? So let me run this. I just pasted, copied from you. So mat1 is this. Oops. So this is your mat1. Now what do you want me to do? You are trying to find the average. You're trying to find the average, right? Okay. So you can find the average using apply mat1. So you want to do it with column or with row? So this will give you the average. Okay. So this will give you the average. Is this what you're asking? Okay. You used sapply. Okay, let me try sapply here. Sapply mat1, and then you use mean. Okay, what is this? Okay. Let's see the help page of sapply. Okay. Let's go and see the help page of sapply and see what we get there. So here we have sapply. Okay, so x, then the function. A function can be applied to each element of x. Okay, to each element of x, see details. No, I think it has applied to each value individually. So one value, second value, third value, fourth value, and so on. And so it is printing everything again. Okay, it has applied to each value. So each value is going one at a time. Okay, yeah, that's a little strange. I think you cannot do that using. Yes, you will get all elements from the matrix because each element is going one at a time, and the average of a single element is the same element. It doesn't change. I think you do not apply. I have always used sapply with data frames. I never tried it with matrices. So I'm not very sure of this. Okay. So I'll get back to you, Pankaj, on this. I will try to see why we are getting this. Even I am not sure, and this is something which is strange to me as well. And honestly, I have never used sapply on a matrix. I have used it on a data frame, but never on a matrix. So let's see. I'll get an answer to this. I'll see why is this happening. There must be a reason. I will try to find that reason, and I'll maybe mail it to everybody. Okay. Okay. So guys, let's see this function thing. So how do we create user defined functions in R? So let's say if we have to create a function which tells you if a number is even or odd. We'll start with a very small example. Okay, so to find if a number is even or not, we write a function. Okay, first we will do it with a loop. We will do it using a loop first, and then we will write a function to do that. The advantage of using your own functions is you can use them again and again. So let's say you are doing some operation and you feel that that operation has to be done again and again. If you write a loop, you will have to copy paste the same piece of codes again, right? But if you write a function, you can just call the function and do that operation. So it saves your time. Okay, and the number of lines you write reduces. So here I have defined a variable, a number 4010 is a number I have defined. And then how do I check whether the number is even or not? I just divide it by 2, and if the remainder is 0, if the remainder is 0, that means it is a even number. So to check a remainder, we use double percentage symbol in R. So I have written if x double percent R is equal to 0, that means if the remainder is 0, print even number. Okay, else print odd number. So we have already seen how do we use if else statements. So that's what I'm using here. So let me run this. It will print even number because of course 4010 is even number. So this is how I have used a simple loop to find if a number is odd or even. Now what I will do is I will write a function to do the same thing. So let's say I have to repeat this again and again. Now I have to repeat it for a different number. So I'll have to again write x and then again run these functions. So to avoid that, what I can do, I can write my own function. So how do we write a function in R? It is like this. You write the name of the function first. What is the name you want to give? So let's say I want to call it even underscore number. So my function's name is even underscore number. And then I write the keyword function. So this function is a keyword. So you will have to mandatorily use this. So I write the keyword function and then I write x here. So x is the input of this function. Okay, this will be the input of function which I will be changing again and again. Whenever I call this, I will be changing this x, and then I use this x for whatever operation I want to do. Okay, I will use this x for whatever operation I want to do. So if x, so the same thing I will copy paste from here basically. Okay, if the remainder is 0, print it is an even number, else print it is an odd number, and I close my function. So the function started here and it closes here. So if you click here, you will see this getting highlighted. So that way you can track your brackets. So when you click on this bracket, you will see this one getting highlighted. Okay, similarly when you click here, this one will get highlighted. So this allows you to track your brackets so that you don't give any additional bracket and get a syntax error. Okay, so even number is my function which will help me identify if the input to that function is even or odd. So let me run this function. I run this function and nothing happens. Okay, so whenever you run a function, you will not get any result because the function has run and it has been stored now. So now R knows what is even underscore number. So even R's IntelliSense, if you see, it will show you. See, it is showing me. So R knows what is even underscore number now. Now we can use that function for any variable we want. So see, I'm calling that function and I'm passing one variable. So 4101, and this is how you call the function. You just write the name of the function and in brackets you write the input. So here I have given only one input, right? You can give multiple inputs also. So since there is only one input, I'll have to pass mandatorily, I'll have to pass one variable, one number I'll have to pass here. So that's what I'm doing here. So when I do this, I get it is an odd number. So what happens is this 4101 will become your x and it will go and execute these lines. So 4101 divided by 2, remainder is 0. No. So it will not go inside the if condition. It will directly go to the else condition and it will print that it is an odd number. Okay. So this is how you call a function and this is how you create a user defined function. Okay. Is that clear, guys? How to write your own function? Okay, again, this is very simple. Similar way you would do in any other programming language. Minor syntax differences might be there, but it has the same logic basically. Okay, so if you want to give multiple inputs, you can give x, y, z. If you want to give 3 inputs, okay. If you want to give some default values of your input, you can write x is equal to 1 here. So if you do that, you will not have to pass your x variable every time. Even with default values, it will run, and so on. That is common for any language. Okay, so all those things apply. Again, user defined functions are also very helpful sometimes when you have to do a complex operation on your data. We generally sometimes prefer to write user defined function instead of just writing loops. Okay, or let's say you want to do something but you don't know if there is any function available for it, or you want to customize a function a little bit, then also you can go for a user defined function. Okay. Okay, great. So the functions part is clear. Now let us come back to the apply function, the apply family of functions, and let us see the application of the apply family of functions. Okay. Or submit. Of course, it can be used. A built-in function can be used, of course. Okay. So now let's come to, now let's say you have a data frame. You have a very big data frame and there are some numerical columns in the data frame. There are some categorical columns in the data frame. Implicit loop. Yes, Vikas. Yes, that is correct. It basically is an implicit loop. So one by one it will go and execute. You don't have to write a loop specifically for that. It does that automatically. That is correct. Okay. So guys, let's say you have a very big data frame. You have some numerical columns, you have some categorical columns, and you want to separate them. You want to find out which columns in your data frame are numerical, which columns in your data frame are categorical. We do this. Okay, why we do this you will come to know later when we start with machine learning, because you analyze your numerical variables in a different way compared to your categorical variables. For example, histogram scatter plot, you can only draw histogram scatter plot for continuous variables. You cannot draw it for categorical variable. Okay, so you have different ways of analyzing a numerical variable and a different way of analyzing a categorical variable. Okay, that is why it is very important to separate them, to separate your independent variable, to separate your categorical variable from your continuous or numerical variables. So how do we separate now? Let's say I have a very big data frame. If it is a small data frame like the iris data, I can directly look at it. I can directly look at it and see that okay, the fifth column is categorical, all the first four columns are continuous. But if it is a very big data with, let's say, 50 columns, then I cannot do that, right? I cannot go and manually count. Let's say I have a column at index number 43 which is categorical. I cannot count 1 2 3 4 till 43 to see that okay, 43rd column is a categorical column. So there has to be a way to do that efficiently. So we can use sapply for that. So we already learned that sapply takes one column at a time, right? Sapply takes one column at a time. So we can utilize this information and then find out if a column is categorical or not, or if a column is numerical or not. So how do we do that? So there is a function called is.factor in R. Okay, is.factor in R, which will give you true. Okay, so there is a function called is.factor. Okay, and you give data frame dollar some column. If this column is categorical, then this will give you true. If this column is not categorical, it will give you false. So is.factor means you are checking, okay, is it a factor, is it a factor? So is.factor. Okay, similar to this there is another command called as.factor. Okay, so what as.factor does is it converts this column to a factor. Even if it is numerical, it will convert it to a factor. But is.factor will just check. So is it a factor? It is just checking. So true and false. As.factor, it will convert it. Similarly, you have is.numeric also. Is.numeric will check if the column is numeric. As.numeric will convert it to numeric, and so on. Okay, guys. So this is what we'll be using. So is.factor, see, is.factor we can use to see if a column is categorical or not. Okay, along with sapply. So what we can write is.factor. We can write, so this input, this x can go on changing. So this x can be column 1 first, then column 2, then column 3, and so on. So that it will give us true and false, right? It will give us true and false. If column 1 is factor, it will give us true. If column 2 is not a factor, it will give us false, and so on. Okay, so this way we can identify if our columns are true or not. And we know that we can do this, we can keep changing our x using sapply function, because sapply does exactly that. It takes one column at a time. We have seen that already, right? So that's what we'll be using. We'll be merging this function along with sapply. So I have written sapply, then I write the name of the data frame, because if I write the name of the data frame, automatically each column from the data frame will start going one at a time into the next function. Now you see what I have written this big thing. Okay, first let me write how you would intuitively do it. So intuitively what you will do, you will write sapply iris, and then you will write is.factor, right? Intuitively this is what you will do. See what we get? We get x is missing with no default. Okay, so intuitively when you do this, what happens is dot factor, you have left it blank. You have left is dot factor blank. Now how would R know that it has to pass the columns inside is dot factor? R wouldn't know that, right guys? Are you following, guys? Okay, so the moment you write this, how would R know that it has to pass these columns inside this is dot factor? So there has to be a way to do that, right? So what we do in that case is we create an anonymous function. Okay, we create an anonymous user defined function. So we will create a very small user defined function which doesn't have a name. Basically we don't give it a name, we just create it and immediately we end it also. So you see what I have done is, let me explain here. So I have created a small user defined function. I did not give any name to it, it is anonymous. So I have written function x. Okay, this is the input of that, and then this is the loop of that function. Whatever I want to do, I will do inside this. Inside this I have written is dot factor, and I have written x here. Okay, now what will happen the moment I write iris here, okay, and I use sapply outside. Now sapply, what it will do, it will take the columns from iris and pass to this function. Now the moment it passes to that function, it comes as a x. That column, one column at a time, is nothing but your x. Now is dot factor knows that okay, this x is coming from here. So I'm basically connecting the three together. Are you following, guys? If I don't do this, is dot factor will never know that from where is the input coming. So I'm just connecting it so that the columns from here will go to function as x, and x from here will go here into the operation, and finally you will get your output. Okay, so if I have to run this, I will write sapply iris function x is dot factor. When I run this, I get a true and false. See, I'm getting true for the last column. My last column is a factor, right? So I'm getting true for that. For all others, I'm getting a false. Did you follow this, guys? I know this might be a little tricky for you. It was for me when I saw it for the first time, but slowly you will get used to it. Okay, slowly you will understand. Yes, guys, tell me, are you following this? Did you understand this? I know you will not remember this syntax so soon. You'll have to practice a few times to do that. uh, yeah, I will explain it one more time. Yes, exactly, Pankaj. X will be taken as each column will go one at a time as x. Each column will go one at a time as x. Anand, can we create a new function? What function do you want to create, Anand? No, you're not creating any function. You are just writing an anonymous function which starts and ends immediately. Okay, which starts and ends immediately. You're not creating any function. You haven't given any name to it. Mohit, what are you asking? Sapply iris function x, then? Mohit, I'm not sure what you're asking. Can you rephrase your question? You were splitting the function. Okay, so you mean taking it to the next line? Yeah, you can do that. You can do that. You can take it to the next line, but it is not required because this function is very small. So you can maybe immediately end it. Okay. Instead of taking it to the next line and elaborating the function, you can quickly end it. So this way it is in fact easier to understand. Instead of taking, if you take it to the next line, it might look a little complex. Yes, Pankaj, that is correct. Yes, the scope of function. So the scope of this function is only inside sapply because there is no name to it. So it ends immediately. It starts here and it ends immediately inside sapply. So these entire things, the scope of this entire highlighted thing is limited inside sapply, not outside sapply. Okay. So no, so naming is not needed. Yes. Okay. So to explain it once again, what do? I use sapply. So the only way you would do it is you will write something like this. This is the only way you would do it, even if you don't know, right? This is the only way you will do it. You will write sapply DataFrame and as dot factor if you want to check, because you already know that sapply will take one column at a time. So this is the first way you would probably try. If I was starting, this is the first thing I would do. But here if you see what is the mistake you are making here, or if I do this, what is the mistake I am making here? How would as dot factor know that what is the input to as dot factor? Because as dot factor takes something as input. You have to give something here. You cannot leave it blank. So here I have left it blank, or even if I write this, I have left it blank. So it needs to have some input. So that input, how will I get these inputs? So df sapply will take one column at a time from df, but that column you are just ending it here itself. You're not passing it to as dot factor. So to pass it to as dot factor, you will have to somehow take the columns from here and put it inside this. Okay, so if I write x here, it will still not work, because how does, like, what is this x? This is the input to s dot factor, but what is the input? There is no connection. It is still not connected. The two are not connected. So to connect the two, I will have to create an anonymous function. So what I will do is I will write an anonymous function. So anonymous function will have no name. I'll just give the input, and immediately I'll start the function. I'll start the operations within the function, and I will write as dot factor of x, and immediately I will close it. So this function is limited to here. It starts here, and it closes here. Okay, and I'll close the sapply function. So what this will do is each column from data frame will be passed as x to the function one at a time. So column 1 will go first, then column 2 will go, and so on. Okay, now once this first column comes here, the operation will be executed. It will check if that column is a factor. Yes, then true. Similarly, it will go to the next column. It will again check if it is a factor. It will get true or false accordingly. And finally at the last it will end. Okay. Yes, Sukesh, that is correct. Yes, Sahana, that is correct. Okay. So now you know how to find out from a list, from a big data frame, how to identify which columns are numerical. Similarly, you can do for numeric also. So here I am doing for numeric. So instead of is dot factor, I am writing is dot numeric. Okay. So this will give you true and false. Now let's say you have to select only the categorical columns. If you have to select only the categorical columns, then what you can do, you can pass this entire thing as an index. Okay, so that's what I'm doing. I'm writing column names here, and this entire function I am passing as an index within the square brackets. So that will give me only the last column as output. So this step you would follow, right? This is what we have done previously. I have passed the output of sapply inside as an index. So the false ones will not be selected, only the true one will be selected. Okay. Okay. So this is your sapply function, how it is used. Similarly, you can find for numeric also. Here I have tried to do a slightly complex operation. So this I will not cover now. This maybe you can see this on your own. Okay. I have tried to explain it. So before you understand this, you'll have to know what does this function do. Okay. What does this function do? Actually, I was planning to cover this also today. I have some other functions that I wanted to cover today. So do you guys have some 10-15 minutes extra time, guys? Shall we finish this off? It's not a lot, only these many. Okay, thanks guys. Mohit, is that okay for you? Because you have been awake for some weird hours, right? It's around 4 o'clock for you. Okay, thanks guys. So let's finish this then. So we were here, right, in apply function. So let me park this for the time being. I'll come back to this after we have learned the string split function. So let's go to our string split function. So let's see a few functions. So that is what we have to do now. So scatter plot we have done, variable types we have done, PDF we have done, joins is done, we have done apply family of functions. What remains is these few functions. Okay, so again there are thousands of functions in R. in any language. Of course, it is not possible to cover all the functions in a short course like this, but I will try to cover the functions which are most commonly used. Okay, for data cleaning purpose, for manipulation of data, the most commonly used functions I'll try to cover now. Okay, there are not many actually. There are some 5-10 functions which are most commonly used. So let's see. So let me start from the beginning. This is nothing but missing value imputation. We have already done this yesterday. Okay. Now let's come to the sort function. Sort function, we have done this morning. So we can give decreasing is equal to true to arrange in decreasing order. By default, decreasing is false, so it arranges in increasing order. Okay. We have already seen that index subsetting by index does not treat the NA. We have already seen this, so we use the subset function for that. Okay. Now let us come to some functions. Okay, let's say I create a vector sports which has these 4 sports. Okay, so I have created a vector called sports which has cricket, football, hockey, basketball, these 4 sports. Now if I write the length of sports, what do I get? Yes guys, if I run length of sports, what will I get? Yeah, I'll get 4, right? Because the length is 4, so I'll get 4. There are 4 elements in this, so I'll get 4. Okay, now let's run another function which is nchar. So nchar function, what it will do is it will give you the number of characters in each of the elements. Number of characters in each element. So see, the first element cricket has 7 characters, 7 letters. Second element football has 8 letters. Same for hockey and basketball. Okay. So nchar will give you number of letters in each element. Okay. So that's the nchar function. Of course, this will not work on numbers. So if you give number as a input, I think it will show error. So nchar, let's say I give 1, 3, 44, 33. Okay, it is giving you. So it will just count basically how many letters are present. So it can be numbers also. So for example, when I do nchar of this vector, it is giving me 1, 1, 2, 2. Okay. So nchar, this is how it will work. To see the data type of anything, you can run is.numeric or is.character. So is.numeric of 1 will give you true because 1 is numeric. Is.numeric of ABC will give you false because ABC is not numeric. ABC is a character. Is.character will give you true. Okay, following guys? I'm just rushing a little fast here because these are simple things. Okay. Now you have factor data type. Okay, so I have tried to explain here. R factor might be viewed simply as a vector with extra information, that is a record of distinct values in that vector called level. Okay, so is dot factor ABC will give you false because ABC is not a factor, it is a character. So right now it is a character. ABC is a character. Okay, so what I will do, I will convert ABC to a factor. I'll convert ABC to a factor, and then if I check is dot factor, it will give me true. Okay, did you follow this line guys? So ABC right now is a character. So a character is different from a factor. Okay, a character means plain text. Factor, a text will always be a factor, but all factors, a factor will always be a text, but all text will not be a factor. Are you understanding guys? So it looks something like this. This is your characters. Okay, factors is like this. All factors are characters, but all characters are not factors. Okay, so character is the superset. Factor is a small subset within that. To be a factor, you have to be a character. Actually, no. A number can also be a factor. A number can also be a factor. Okay, you can convert a number also to a factor. So for example, let's say you can convert it forcefully, so it has a small thing outside also. Okay, so whenever you read a data frame, whenever you read a data frame so this is important, guys. Whenever you read a data frame, all characters are by default read as factors. Okay, so whenever you read a data frame, all characters are by default read as factors. That is why in the iris dataset, you saw in the iris dataset, right, the fourth column was read as factor because it was a data frame. So by default it will be read as factor. Even if you read a file from a CSV, so read.csv, when you use, yesterday we saw, right, we were using read.csv. So when you use read.csv, it automatically reads the character as a factor. Okay, so I'll just show you read.csv. If you write, it will automatically read the character as factor. If you don't want to do that, what you write, see this there is an optional argument, strings as factors is equal to false. You will have to give this argument. By default it is true. So what does it mean? By default all strings or all characters are read as factors. So by default it is true. If you don't want to do that, you will have to specifically write false here. Then it will not read the character as a factor. Okay, so we will see this later when we do the case studies. So right now just understand that factor is a data type in R, which is usually for characters. Okay, so let's move ahead. I'm creating a vector here which has a few letters. So superset is the name of the vector. I'm creating a smaller vector called sample which has a few other letters. Now I want to find, so so now we are trying to study this. What does this do? Percent in percent. Okay, this is very important. This is used to find the intersection of two vectors. So let's say you have a vector A, you have a vector B. Okay, you have a vector A, you have a vector B. If you want to check the elements of vector A which are present in elements of vector B. Yes, Siddharth, exactly. We do that, yeah. So to check which one, whether the elements present in A is present in B or not. So that we can do using percent in function. Okay, so let's see how it works. You will understand. So these are two vectors that I have created. One is superset, so it is A, B, D, so on. One is sample, which has a few smaller vectors. Now when I run this, let's see what happens and then I'll explain. First let me run this. Let me run this first and then maybe I'll run that one. So when I run this, see what am I getting? I'm getting a Boolean vector, right? I'm getting a Boolean vector. So what is that giving me? It is checking for each element in the first one. So sample I have given first, right? So for each element of sample, it is checking whether it is present in superset or not. So Q, is it present in superset? No. So it is giving me false. A, is it present in superset? Yes. So it is giving me true. Again, L, is it present in superset? No. So it is giving me false. D, is it present in superset? Yes. So it is giving me true. So that is what your percent in percent does. Okay. This is very important, guys. This is used a lot. Not very important from an interview perspective. People will not ask you these questions in interviews. But when you are working on some data set, it is very helpful. Okay. Did you follow, guys? Did you follow this? Okay. Okay, great. Now let's say if you want to filter out only those elements in sample vector which are also present in superset. Okay, if you want to filter out only those elements, so for example I want to filter out A and D. Only A and D I want as my output. Okay, I only want the intersection of the two basically. I don't want all. I want the intersection of the two vectors. So in that case, I can use indexing. So this, whatever you learned earlier, I'll put that inside the index. So that will provide the intersection of the two. So you see it is giving me A and D. So A and D is present in both. Okay. So let me write it down here. It gives me the intersection of the two vectors. Okay. Don't mind the spellings. Okay. Similarly, if you want to know the index, you can use the which command for that. So which will give me the index. So the second vector, the second element and the fourth element of sample is present in superset. So basically I'm showing you different ways of using this function. The %in% function, there are different ways of using it. You can use it this way to get a Boolean vector. You can use it this way to get the intersection of the two vectors, or you can use it with which command to get the index of the vector, index of the elements which is present in both. Okay, so different ways of using the same function. Okay, now okay, this one we have already seen. This is another way to, so this and this one is equivalent. These two are equal. Line number 48, oops, line number 48 and line number 53 are equivalent. Okay, it is not mandatory to use which inside. You can directly use this also. Both will give the same output. Okay, now we have seen how to get the intersection of the two, right? How to get the intersection of the two we have seen. So let me discuss this here. So let's say I have a vector A here, I have another vector B here. So how do I get the intersection? If I just write A %in B, what do I get? I will get a Boolean vector. Which will tell me for each element of A whether it is present in B or not. So for this one I will get true, but for the others I will get false. Right guys? Are you following? Guys, are you following? Okay, great. Okay, so this will just give me a Boolean vector. But let's say I only want this as the output. I don't want a Boolean vector. I want this element which is present in both. So the intersection. So how do I do that? For that I will write the same command A %in B, but I will write it in the index and I will write A outside. So this is equivalent to writing A and this Boolean vector, right? This Boolean vector will come inside. So Boolean vector here. So for the false, it will not be printed. So the index which is false will not be printed. Only the ones, so only this one which is true will be printed out. Only the true one will be printed. So this is how you find the intersection. But now let's say I want to find, I don't want to find the intersection. I want to find the values in sample not present in superset. Okay, I want to find basically A minus B. So this one is what I want to find, the other elements. Okay, so for that what I will do, I will just use the not notation. So this not you see here, this not will give you the opposite. It will give you all in A which is not present in B. So you see, now I am getting Q and L. Earlier I was getting A and D, now I am getting Q and L. Okay, or in another way you can use the negative sign also if you are using which, because which will give you the index, and the moment you give a negative sign it will omit those indexes. So it will not give you 2 and 4 elements which are at 2 and 4, it will give you everything else. Okay, so to do A minus B, what I will do, I will just write A, okay, and I will write not, and then I will write a percent in B. So this will give me this red color, this red shaded portion. Okay. Or in another way, what I can do, if I am using indexes, I will write which A in B. Okay. If I just run this, what will I get? I will get this one. I will get this one. But the moment I write minus of the same, minus, if I write minus here, I will get this one. Okay. Is this clear, guys? Okay. Okay, guys. So I think this is clear. Then similarly, we have a paste function. Okay. Again, there are many functions like this. It is not mandatory to cover everything, but let me cover as much as possible. And I have tried to give a lot of comments. Okay. So even if I don't finish this today, you can just go through it on your own, and I'm sure you will understand. Okay. Of course, you can always get back if you have any doubts. So let's see what is this paste function. Paste function, what it does is it will just paste the inputs that you give it. So I have given two inputs here, A and B, and it has a separator argument. So separator is nothing here. I did not give anything. I just opened the quotation and closed the quotation. So what it will do is it will just paste A and B together. So the output is A and B. Now you see I have given a separator as 3 plus signs. So it will do this. So very intuitive, nothing to explain here. Now if you, let's say if you don't give the separator, so by default it has a space as a separator. By default a space is taken as a separator. Okay. You can give any random symbols also as a separator. So I have given this arrow as a separator here. Okay. So that is the paste function for you. Now let's come to something called pattern matching. Let's say you have, so for that we use the grep function, grep function. So what it does is this function searches for matches to pattern within each element of a character vector and returns an integer of the elements of that vector that contain a match. Again, the theory might be intimidating. Let's see it in action. Okay. So X is, I have defined a vector, apple, potato, grape, 10, blue flower. Okay. I've defined a vector here. Neha, no, Neha, that will not work. I think you can try. Let me try. Let me try. Because see, minus of false is not true. So the inside index what you have written will give you a boolean, and minus of false is not true. So I think it might not work. Let me try anyways. So let me copy paste it here. So I don't think it is giving the correct output. Is it? Sample in superset. ALD. ALD is what it is. You know, it did not work properly. You see, it should have given you. So what are you trying to do basically? You are trying to get all the things out which is not present in superset, right? So your answer should have been Q and L. Your answer should have been Q and L, but it gave you some weird result. So the ideal way to do this would have been using which here, which would have given the correct answer. Okay, so that will not work. So you'll have to be careful. Why it didn't work is because minus of true is not false. See, minus of true will not give you false, or minus of false will not give you true. So that is why it didn't work. Okay. Okay. Let's come here. So we were talking about grep function. So I have defined a vector x which has apple, potato, these 5 items. Now let's say if I have to search, find the index of all elements in which contains the word A. So I just want to do a pattern matching. I want to see where is that word A present. So A is present in the first element, in the second element, in the third element. Okay. Fuck. Guys, can you hear me now? Oh, that was an internet issue. Okay, no power issue. Okay, so so let's do now. So I want to search this word a in all the elements here. So I will use grep function, grep a of x. So let's see what I get. See, what am I getting? I'm getting 1, 2 and 3. So what is this 1, 2 and 3? These are the indexes of element where the letter a is present. Okay. So my letter a is present in the first element, in the second element, and in the third element. That is why I'm getting 1, 2 and 3. So grep function gives you the index. Okay. Always remember, grep function gives you the index, not the element itself. Okay. Now, if you want the element itself, what you'll have to do, you'll have to give value is equal to true. Okay. Value is equal to true. If you give, then you will get the element itself. In which element is that word present, you will get the entire element. If you don't give value is equal to true, you will just get the index. Okay. So that is where grep function is used. Okay. Another way to use grep function is you can use grep L. L stands for logical. What this will give you, for each element it will give you true false, whether that letter a is present in the elements or not. So in the first element we saw it was present, so it is giving true. Same for the first three elements. In the first three elements the letter a was present, so it is giving true for the first three elements, and then it is giving false. So grep L, L stands for logical. You can use this or you can use grep function also. Okay, so that is the grep function. Now let us come to string split function. Okay, string split function, I have written what it does. It splits a string into a list containing multiple strings based upon a delimiter. So based upon whatever delimiter you give, it will split a string into multiple parts. Okay, and you see here it splits the string into a list, so the output will be in the form of a list. So that means you will have to use double square brackets to access it. Okay, so let's see an example. So I have a list called word. I have a vector called word, which is this apple, lime, orange, and you see this pipe operator in between. Now I will try to split these words based on the pipe operator. Okay, so what I will write string split, the name of the vector, and then I will give the separator. So the separator is the pipe. Okay, and fixed is equal to true. So when I do this, what will I get? I will get apple, lime and orange separated. And you see this double square brackets, that shows that this is a list. You can also see using the class function. So if you write class function and you put everything inside that, you will see that it is a list. So the data type of the output is a list. Okay, this fixed is equal to true is mandatory. If you don't give this, you see the output, it will not make sense. You will get all the words separated. Okay, so that is why fixed is equal to true is mandatory here. Okay, now you can, yeah Neha, if you don't give fixed is equal to true, it will split based on every letter. Basically it will split each letter. Okay, now you can access individual elements from the output list. So after this, you can obviously, once you get the output, you can access individual elements. Let's say you want to access lime and orange. So how will you access lime and orange? So this is nothing but a vector, right? So you will use first double square brackets to access the vector, and then after you have accessed the vector, you can use normal indexing to access individual items within the vector. So this we have done earlier. How do you access individual items within a list? So that you can use. So let's say example, to access lime, I will just run this and I will access lime. So this kind of looks scary, but it is nothing but if you break the problem into smaller piece, this becomes very easy to understand. Okay, and so I think that is all, guys. So string split is done. This is nothing but I'm trying to do some basic operation, table function and all, which you already know. Okay, similar to table function, there is one prop dot table. So table function, for example, will give you the count of each category, right? Table function will give you the count of each category, each unique category. If you want the proportion, you can use prop.table. Okay, so this prop.table outside the table function will give you proportion instead of the count. Okay, so it gives you the proportion. Yes, Siddharth, I will do that. I have sent the Excel also via mail. Okay, so I think this is all that we needed to cover today. So thanks guys, we covered a lot today, and I'm really happy that I was able to cover all of this. So that will allow me to uh, go as per the planned way. Okay, a lot of times what happens, I skip something, and then later it throws my plan into jittery. So it's good if we go as per the plan. So I don't want to spend a lot of time learning R, because learning a language is a continuous process. Okay, it takes time to learn. You will not become a master of R in 1 week or 2 week. It will take time. So what I want to focus on is the machine learning part. R you will eventually get slowly, and even when you are working on machine learning, you will be using R eventually. So of course you will be learning again and again. Neha, I have already sent this Excel to you. I have sent this Excel already. Okay. No, yesterday I did not send. I send this Excel only once a week, not every Saturday or every Sunday. I'll send it only once every week. So after Sunday, I will send this Excel every time, because this will be updated again and again, right? So I'll send it every after every Sunday's class, not after Saturday's class. Okay. Okay, so that's all I had for today. Let me do a quick revision and then we can close for today. What will happen? So Pankaj is asking what will happen in case of string split if the string is. Pankaj Gupta will. Okay, let me show you, Pankaj, what will happen if you have this. So you can run basically. So let's say you have the string's name is this. Let's say. So this is the string you are asking, Pankaj. So you write. So basically you will get Pankaj Gupta separate, Indian separate, ENGG separate. Okay. So strsplit string split D, and you want to split it based on pipe, the pipe operator, and you write fixed is equal to true. So this is what you will get. Yeah, you will have three elements. It will not split based on the space. Okay, because you have explicitly mentioned that you want to split based on pipe. If you don't give that pipe, then see what happens. If you don't give the pipe, then basically it will not split based on anything. If you split based on space, then it will split. So let's say if you want to split based on the space, so I give a space here, then it will split Pankaj separate and the other part separate. Okay, so let's come to the revision part, guys. So we covered a lot today, so where should we start? Okay, so what did we see at the beginning of the class? We saw the different variable types. We saw that broadly there are two types of variables. One is numerical, one is categorical. Okay, numericals are all numbers. Okay, like your height, your weight, the number of children somebody has, the number of cars somebody has. These are all numerical variables. So actual numbers. Okay, numerical variables are all actual numbers. Now I can write male as 0 and female as 1. That doesn't mean that this variable is numerical. Male female are not actual numbers. Just because I'm representing them as numbers doesn't mean their data type changes. The data type will remain the same. They will still be categorical. Okay, so remember that. So numerical, again, this has two divisions. One is continuous, the other is discrete. Discrete is like number of cars you have, number of children somebody has. So they cannot take decimal places. Continuous can take any decimal places. Within categorical, we have again two types. One is nominal. Nominal are the categories which do not have any intrinsic order in them, like colors, like the company you work, the countries we stay in, the cities that we stay in. There is no order in that. So those are all nominal. And opposite of this is ordinal. Ordinal is where you have an intrinsic order. My voice is dying now. Just a minute, I'll have some water. So ordinal is where you have an intrinsic order. So for example, low, high, medium, there is some order to that. So that those are all ordinal variables where there is an intrinsic order to that. Okay. Yes, Anna, of course. Discrete doesn't mean that it has to be positive. It can be negative also. The only thing is that it cannot take decimal values. So it can be -1, -2, -3 also. Okay. So, okay. So after this, what did we see? We saw how do we do joins. We saw how to do joins. Negative, Sana, that's what. It can be, but I cannot think of any example. I think I have never seen a negative discrete variable. Because you always have it as positive, but that doesn't mean you cannot have. You can have, but I cannot think of any real life example where you have a negative discrete variable. It is usually positive. So discrete variable is usually used for counts, for counting something. Okay, for counting something you use discrete variable. So you obviously will not count something which in negative numbers, right? But theoretically they can be. Okay, by definition. Okay, then we saw joins. We saw what is outer join. We saw what is inner join. So outer join is where you will get no information loss. Okay, no information loss, but you will have NA values. You will have NAs. Inner join means no NAs. So when I say, guys, when I say no NAs, if internally a data has NAs, then of course it will have NAs. But while merging, there won't be any NAs coming in while merging. But internally, if a data has NAs, it may still be there. Okay, but there will be loss of information. Okay, that is your inner join. Then we also saw left join. Left join is where one of the table will come as it is and the other data from the other table will start coming if it matches, but one table will have everything. So you might get some NAs in a left join, but from the left hand side table you will not lose any data. From the right hand side you may lose data, but from the left hand side you will not lose any data. So similarly is right join. Here on the right hand side table, from the right hand side table you will not lose any data. From left hand side you might lose a data if it doesn't match. Okay, the way to do this in R is you use the merge function. You write your X, you write your Y. If your column names are same in both X and Y, the merging column, then you write by name of the column, and you write all is equal to true if you want to do outer join. You just leave it if you want to do, so all is equal to false if you want to do inner join. All dot X is equal to true if you want to do left join. All dot Y is equal to true if you want to do right join. Okay, and if your column names are different in the two tables, you can write by dot X, the name of the column in the X table, by dot Y, the name of the column in your Y data frame. So this you can use to do joins. Okay, next what did we see after this? We went to user defined functions. So the way to write that is you write the name of the function, then you give equal to, then you write the keyword function, then the inputs of the function. You can have multiple inputs. Then you start a loop, and whatever you want to do, you do inside this function. Okay, and the last line of the function is return. Okay, if you don't write any, so you can write a return statement here. Okay, return some variable k. So k will be the output of this function. If you don't write this return k, whatever is the last line will be the output. Okay, So that is your user defined function. Next we saw the apply family of functions. Yeah, okay, let's do the PDF first. PDF is very simple. PDF is nothing but histogram, but you have replaced. So PDFs are nothing but probability density functions. They are same as histograms, but on the y-axis they have probability. Okay, they do not have count, they have probability. So it will be less than 1 always, and the area is 1. The area of a PDF is 1. Okay. Scatter plot, again simple. Scatter plot is a plot between two variables. One variable you take on x, one you take on y. You use the simple plot function in R. You give your first vector, the second vector, and then there is type is equal to, you can give p for points, you can give l for lines, you can give b for both points and lines, and so on. Next we came to the apply family of functions. We saw what is a normal apply function. Apply function takes three inputs. First input is the object. It can be a matrix, it can be a data frame. Next is one or two, depending upon if you want to do a row operation or a column operation. And finally the function that you want to apply. So it can be mean, median, max, whatever. Okay, this is your apply function. Then we saw tapply. Tapply again takes three inputs. The second input is usually a categorical variable based on which the data will be divided. Okay, and after the data is divided, the third input, which is usually a function, is applied on the first input. Okay, first input is usually a continuous variable. Okay, so you divide your data based on the second input, and then you apply the third input on the first input. That is your tapply function. Next we saw sapply. So sapply is similar to apply function with 2. Okay, because it does a column operation. So you write the object, it can be a data frame, and then you write the function that you want to apply. Okay, so here I have a doubt which Pankaj asked, so that will be something which I'll keep in mind, and I'll get back to you on that. Okay, and then we saw lapply. Lapply is also similar to above. Okay, but the output is a list. So L stands for a list, the output will be in the form of a list. We saw two very specific application of sapply, very useful application. One was sapply, you write the name of the data frame and you use it to identify which columns are categorical or which columns are numeric. So we use it along with the function, along with the anonymous function. Okay, so this will give you a boolean list. This will give you a boolean vector which has true for factor columns, otherwise false. Okay, and then what else? Okay, we saw some other functions. What other functions did we see? We saw the %in function. So %in function is used to find intersection of two vectors. Okay, intersection of two vectors a and b, so shown by Venn diagram. You can find this a intersection b using this %in %, or you can also find a minus b using the same %in %. You will just have to use the not operator. Okay, then we saw the grep function. Grep is used for pattern matching. If you want to match a pattern, you can use grep. Okay, so grep, what it will give you? It will give you the index. By default it will give you the index of the elements where that pattern is present. If you want the element itself, you will use value is equal to true if you want the element itself. Okay, Then we saw, after that we saw grepl function, which gives you a logical vector, so true false, whether the element is present or not. Okay. And then finally we saw the string split function. String split function, what it does, it splits a string, as the function name suggests, string split. It splits a string based on a separator that you provide. So you write a string, let's say your string is x, and you provide a separator. So it can be anything. We saw an example with the pipe operator. Okay, so that means it will separate the string x based on wherever it sees a pipe, and you just have to give fixed is equal to true here. Okay, and the output of this is in the form of a list. So if you have to access individual items after splitting, you will have to use double square brackets, not single square bracket. So that is something which you have to remember. Okay, anything else, guys? I think this is all that we covered today, right?